In this video, we will look at exploration 6.4.2 and work through number 7, where we are going to show that the angle form and the component form of the dot product are equivalent. So let's begin by looking at number 7 from this exploration. We consider this picture of two vectors in the plane with an angle of a minus b between them, where v has an angle A from the horizontal and W is at the angle B from the horizontal axis. Okay, so we've got these two vectors, V and W. We have the angle in between them is A minus B. This angle is angle A and this angle is angle B. So it shows us some different pieces to this. We want to note that V sub X is equal to the magnitude of V cosine of A, and V sub Y is equal to the magnitude of V sine A. So that's the X and Y components of vector V. And similarly, vector W also has similar components. And we know that V dot W is equal to the magnitude of V times the magnitude of W times cosine theta. So we want to use this provided figure and a trigonometric identity to show that the angle form and the component form of the dot product are equivalent. So in order to do this, I'm going to start with a picture that we're given as well as the information that we're given. And then I'm going to remind myself of what the definition is. So the definition is when we let the vector v equal v1, v2, so like v sub x, v sub y, and the vector w, which equals w sub 1 and w sub 2, so like w sub x or w sub y, be the two vectors, and let theta be the angle between them. Okay, so we're thinking theta is the angle between the two vectors. Then the dot product of v and with w is defined as this, which we're given right here, but just another like definition to remember. And then the dot product can also be written in component form. So v dot w equals v sub 1 w sub 1 plus v sub 2 w sub 2. So let's actually go from beginning with this, the component form, and going to the angle form. All right, so to begin, I just want to remind us that the vector v is composed of components v sub x and v sub y. And vector w is composed of w sub x and w sub y. Okay, so now let's put that into component form. So thinking vector v dot vector w is vectors, is the components dot the components, which if I just replace the components with the information that they gave me here, so such as v sub x is equal to the magnitude of v cosine alpha, I got that from right here. This is the information given in the problem. So I'm just going to replace these components with their equivalents from here. Okay. And then if we actually used this definition and we multiplied it out component by component, we will get v sub x, so this part, times this part. So v sub s, so that's how I got here. So magnitude v times magnitude of w, cosine alpha, cosine a, cosine b, and then plus we will multiply together their y components, which gives us the magnitude of v, magnitude of w, sine a, sine b. All right, now I'm going to do a little bit of algebra, and I'm just going to factor out the magnitude of v and the magnitude of w from both of these pieces, both of these terms, so that I'm left with cosine of a times cosine of b plus sine of a times sine of b. Now this part should look a bit familiar, this cosine a, cosine b plus sine a, sine b. Where have we seen it before? With our trigonometric properties. So if we look back at our trigonometric properties, we know that cosine of a minus b is equal to cosine a, cosine b plus sine a, sine b. That is a trigonometric property that we had back in unit 4. And if I replace this with cosine of a minus b, I should get this. And if I remember that a minus b is the angle between these two vectors. So according to the definition, a minus b is the theta because it's the angle between the vectors. And so that brings us to v dot w equals the magnitude of v times the magnitude of w cosine of theta. And there you go. There's our proof from going from component form to angle form.